Under the subject of manufacturing technology of a degree semester 5 in mechanical engineering department, today we are going to see the experiment number 8, which is to study about permeability of sand using permeability tester. Permeability is the property of a molding sand that allows air and gases to pass through it. During metal casting, gases such as air, moisture vapor, and combustion gases must escape through the mold wall. If these gases are trapped, some defects like blowholes, gas porosity, or surface defects can occur in the casting. So, to measure the permeability of sand, it is crucial. So we are going to see how these tests can be carried out to maintain the good quality of a casting. So the apparatus required will be first is the sand permeability tester, the sand specimen usually of a 50 mm diameter to 50 mm height, stopwatch to record the time, pressure gauge to know the pressure, and dry and prepare molding sand. So let's see how the permeability tester looks like. So this is the permeability tester. You can see the sand specimen is there. Then the pressure manometer is there. Water seal is there. Inverted bell jar is there. And we are going to pass the 2000 centimeter cube of air through this tester. So let us see the formula for calculating the permeability. So the formula is P is equal to V into H divided by P into A into T. So the P is the permeability number which is dimensionless. Then V is a volume of air passed in centimeter cube, and we are going to pass the 2000 centimeter cube of air through this particular permeability tester. Then H is the height of the specimen in terms of centimeter. Then P is the air pressure in terms of gram per centimeter square. A is the cross sectional area of a specimen in terms of centimeter square. And T is the time for 2000 centimeter cube of air to pass. Either we can record it in terms of minutes or seconds. So the procedure of experiment. So first step is specimen preparation. So we will prepare the standard specimen using sand rammer to ensure uniform moisture and compaction. Then mounting the specimen. Place the specimen in the permeability test chamber and seal it properly to avoid air leakage. Third one is a air supply setup. So we will set the air pressure at 10 gram per centimeter square using the pressure regulator. Now we are allowing the 2000 centimeter cube of air to pass through the specimen. We will measure the time required for the airflow using stopwatch. We will also note down the corresponding pressure on the gauge. And then we will calculate the permeability using the equation which we have uh, seen in the previous slides. So the conclusion is if the sands having a higher permeability, then it will allow easy escape of gases, but this will also lead to the reduced surface finish. And if the sands have a lower permeability, then though it will give smoother surfaces, but there will be a risk of blowholes and other defects. So it is essential that an optimal permeability value is required depending upon the type of casting and metal poured.